Okay, hello year 10. This is my sort of minimum build for the lifting project. I have set it up so that we can have a one-stage lever arm that allows us to lift our mass. This will go up 100 millimeters and it will always fit within size perimeter, and you have to just follow my steps to create these arms. There is no maths required, don't stress about that for the CAD. Okay, so how we're going to build this is we're going to go File, New, and start a new design. And we're going to make sure we pick Hybrid Design Studio. You want distances in millimeters and units in grams. Create. We're going to start by creating what is called a geometry sketch, which will allow us to have all of our sort of sizes determined without having to do any maths working out where they should be. So we're going to start this by creating a rectangle, and we're going to make it a construction rectangle, and we're going to define this to be the size of our object. So we're going to go D for dimension, pick here and go 200 this way and 200 this way. Now if we zoom out, you can see this square. The next thing we want to do is position our sort of movement of the object. We know it needs to move 100 millimeters vertically, so I'm just going to draw a line that is vertical, and I'm going to hit dimension for this and go 100 millimeters, like so. If you would like to be safe, we might go 110, just to make sure we're going over that 100 millimeters. Here we go. Now, we are going to draw a circle using this circle tool, and we're going to have it touch both the top and bottom point of this line. To do that, we're going to use the coincident tool, and we're going to select this point and this circle, and it will stick them together. And then we can do the same thing with that point and that circle, and we'll stick those two together. Now, the path that the arm is going to take will actually be this arc path. It won't be the straight line up and down. So we need to make sure we don't go outside of this sort of bound when we're traveling along this arc. So how I'm going to do that is I'm going to draw another line that's going to go here to here. We're going to make sure that this line is also vertical, boom, and we're going to make sure this line is tangent to this circle. Okay, this will allow us to dimension the gap between the path that we're taking and the edge of the box. And I'm just going to choose 10 for now, 10 millimeters. Okay, now the center of this circle will be our fulcrum point. We don't know how big that is going to be, so this can kind of be wherever we want right now. So we're just going to sort of create the other side of our fulcrum point, which is going to go through, and we'll be able to create some of the things that are defined based off that number. So we're going to do another circle that starts at the origin of that first circle, and it's going to come out like here. All right, this will hopefully be bigger to give us a mechanical advantage. Now, it doesn't matter if it goes out on this side of the line because it'll be traveling over here. However, we do need to make sure it doesn't go past this line, and we don't want our arm to need to go through the floor. So we're going to start by creating a line that starts at the end of this point. It's going to make sure we go through here, and it's going to come touch here. Okay, so it's coincident to there, it's coincident to there, and we just need to make sure it's stuck to the middle here. So we're going to get the coincident tool, pick the center of that circle, and go like that. And then here is our first arm, and then we need to get the second one, which goes up. So we're going to draw a line. I'm going to start at that bottom point. I'm going to go through this middle point and then up to here. So it'd be like this. And then we just need to stick those two together. So coincident, and we go there and there. Okay. Now, the last thing we need to make sure is we don't do this side. So we're going to do the same thing as we did here. We're going to get a line. It's going to be a vertical line that goes down like this. And we're going to make these two tangent, which just means they touch. So we're going to get the circle and the line, make sure they touch, and we're going to make sure this line is vertical as well. And this will allow us to dimension this distance here as 10 mil, or the same as the other side, right? So now this can go up and down, but we can't move side to side anymore, I don't believe. We can. It just sort of changes the lever arms. So the smaller the center circle is, and the bigger circle is, the more leverage we get. Okay, so some other constraints is we can't have our starting point be above that point, and we can't have our end point be below the ground. Okay, so what I'm going to do is I am going to set up a dimension between this point and the line, a distance here, and I'm going to go 5, and then we can do the same thing here, but because there's going to be a base at the bottom and there won't be a top on it, this has to be a little bit bigger, so I'm going to go 8 for now. All right, and you'll notice that actually fully defines where this is going to be. Okay, and then if this is double that size, then we've got a 2-to-1 lever arm. All right, so we now have all of our geometry worked out on the movement of our arms. We just need to create the actual components. So we're going to turn construction lines off because we know where everything is going to be. We're going to go to the create menu, pick slot, and center to center slot. This will give us a really nice looking lever arm. What we can do with this is we can pick our bottom starting point, and we can go to our top end point, and then we go out sideways a little bit, and we are able to specify our lever arm. We're going to make this approximately 10 mil wide, like so, and you'll see that all of these lines go black. Black is good, black is amazing. All right, the final thing we need to do is we need to add some holes in this bar. For the first one will be for our fulcrum point. We need something for it to rotate around. The next will be for something to tie the load to, and the final will be something to tie our rope to so we can pull on it nice and easily. Now, I am going to dimension all of these to be 5 mils in diameter as just a really nice standard sort of unilateral size that we can use. So, like so, we've got them all at 5 millimeters. Okay, the next thing that needs to happen is this fulcrum point can't just float in space like this. So we need to create a stand that they can sit on. So I'm going to start that stand by creating a nice, just like ground floor piece. That's just the full size it can be, like so. And we can specify the thickness of this. So I'm thinking I'm going to use 5 mil plywood for this. I'm going to dimension the height and type in 5 millimeters. Boom, like so. Finally, I need to create a nice big sort of hole that sticks up that we can bolt it to. I'm going to use some radiator pine for that. So I'm going to draw a box like this. We can cut our radiator pine into a nice strip. I'm thinking 50 mils is probably a good, well, let's go 30 mils. It's probably wide enough, like so. And then we want to have this hole in it so it can kind of go anywhere. However, I think we want to have it in a neat-ish point. So what I'm going to do is I'm going to dimension the distance from this hole to the top of the bar to be 20, so that doesn't go too high. And I would also like to have it centered, right? You don't want to have your hole too close to either edge. So the way I'm going to get it centered is I'm going to pick the line tool. We are going to go back to the construction line. If you hover over this line and you find the point where there's the triangle, that is the middle of that line. You click there, you just drag straight down, and you have this line that is centered. So then finally, we're going to select this blue line, the center line we just had, right, which you could mark with a scribe or a pencil in real life. And we're going to stick this hole on it. So we're going to use the coincident tool and stick those together. All right, and now we know where that hole will be. We know where our lever arm will be, and we know the motion of everything. So that's actually all of the sketching we need to do for the majority of our components. we're going to hit finish sketch and we're going to look at it from the side. Now, I'm going to start by extruding our base plate, probably one of the most important parts. We're going to pick a new component. I'm going to change one side to two sides. This will allow us to bring this distance out, the 19 nils, which is the thickness of the pine wood we're going to use here, on one side, and then the other side we're going to take it to the full 200. So I'm going to go 200 minus 19, which is 181. Okay, and that's going to go like that. Now, we do need to extrude more things from that sketch. So we're going to go into the sketch drop down menu and hit sketch 1 and turn the little eye back on so that you can see it again. The next step I would like to do is extrude out this bar piece that we made. I'm going to go new component and we're going to go distance 19 millimeters, like so. Okay, and that sits there like that. The last thing we need to create from that original sketch is our actual lever arm. So we're going to select the parts of our lever arm, which would be those three parts. We're going to go new component, and I'm going to put this, I'm going to use 5mm timber, same as the base, but I want it to go in the other direction to where it's currently going. So I'm just going to put a negative in front of the number to make it extrude in the other direction. And then we do OK, and we can hide that original sketch. Now we have our three pieces that we've drawn. We're most of the way there. So what I would like to do now is start by sticking these two pieces together in the correct location. And so what I'm going to use is join as built joint. All right. And then we're going to click on that. I'm going to click the base plate and our vertical bar. All right. I'm going to make this a rigid joint. This means it can't move at all. And then we hit OK. So if I click this, this doesn't move. This doesn't move. Excellent. But our lever arm still does. Put that back. So how we can fix this is by doing a join as built and picking our lever arm and our solid body, but then changing the rigid to be revolute. What this will allow us to do is select this cylinder and you'll see it starts to spin. Okay, so we now have this as a piece that kind of moves up and down for us when we drag it. However, I feel we would like to have a second sort of lever on the other side so that we can support the mass from both the left and the right. So how I'm going to do that is I am going to start by doing a offset plane. And we're going to drag this out, and I believe it's 80 millimeters from memory to about there. Okay, let that load in, and we have this plane here. What that's going to allow us to do is instead of redrawing everything and all that jazz, is we can come down here to mirror mode, and then the objects we want to mirror are going to be that object and that object. And then the mirror plane is this plane we just created. We go OK. We now have that generated, but these pieces move. So instead of having them move, we're just going to do those joints again. We just did. So as built joint, click this piece, and make sure that's rigid. Okay. And then finally, join as built, this piece, and make sure that's revolute. Now we need to choose where it can revolve around, which is this bolt hole we just drew here. So we're going to include that, and then we're going to go OK. Finally, these now move, right? We have our two sort of lever arms that we want to join together. So what we're going to do is I'm going to do a dowel, which is a round piece of wood. Then I'm going to run from left to right on both the top and the bottom here. Okay, so how I'm going to do that is I am going to start a new sketch, and I'm going to put it on this lever arm, like there, right there, like that. And what I am going to do now is I am going to hit P on the keyboard, which brings up this project menu. which means we can click on different shapes and we'll get those shapes into our sketch, right? So we can click there and hit OK, and we now have this circle, which allows us to just do an extrude. We can go two-sided extrude. We're going to, and now we're going to change this. Instead of typing distances in, we're going to go to object to make it more interesting. We're going to go one goes this way, and I'm going to go to object over here. And this one is going to go to the other side, which is to here. Now, in our list operation, when instead of having join, we're going to go, you guessed it, new component, and then go OK. So we have this piece that sits where we want it to sit. And we can set up a joint between this circle and that hole. Now, in my mind, we'll probably glue those two together. So I'm going to use the rigid joint just so they can't move, like so. And you'll see that we have this arm and that bar moves up and down with it. However, we want to have it glued to this side as well. So we're just going to do that joint again, joint. And then we're going to click that circle and that circle. And they don't move either. And this allows us to grab this piece and both sides move at the same time. Okay, now I'm going to get this piece, and what I'm going to do is I'm going to right click on it, and I'm going to pick move and copy. And then I'm going to click create copy over here in the drop down, create copy, and we're just going to move out a copy of that piece. Why we want this is we want to have another one of these bars at the bottom. So we're going to go joint, I'm going to click the center of that circle, the center of this circle, and have them go together. Boom, like so. So now you can join at the other end. Don't have to though. It's okay now. In real life, we'll glue it in both points. We have this lever system. Okay, so the final things we want to add is the mass that we're going to lift. So what I'm going to do is I am going to do our final sketch. I'm going to pick this top plane here. And we're going to go capture position. Okay, now the discs, the masses we're using are 75 mils in diameter, I believe. So I'm going to hit D for dimension on that circle I just drew and bring this out and type in 75. Boom, like so. The final thing I want to do is I actually want to have it positioned in a fairly neat position so that it can lift up and down. Now, I never said that the weight had to always stay within the zone, so I'm actually fine with it floating out like this. What I'm going to do is I would like to get it centered on this bar. So what I'm going to do is project, P for project, and project this bar here, and then hit OK. And you'll notice there's a dot here and a dot here. And then there's another two at the bottom. So what I'm going to do is I am going to get a construction line that goes from one of the bottom dots we just drew there to the opposite top dot right across on the diagonal. Okay. Can I show you that line easily? Yes, I can, which is this line here. All right. So what I want to do is I'm going to get this line. I'm going to hit midpoint. I'm going to stick it to the center of that circle. And you'll see it went black immediately, which means it can't move it. So we can finish sketch there, extrude these points out, go 40 because it's 40 millimeters tall, and making sure we change that joint to new component. Okay, so here's where our sort of bar will sit, and this component, it can sort of float around. So what I'm going to do is position this just roughly so it fits and it seems like it's in the right spot. Like this, seems pretty good. Okay, and finally we're going to go assemble as built joint, click on this object and this object, and we're going to pick revolve around here like so, and you'll see that spins, and then we can go okay. And the final thing we want to do is if we look at this, lift it, you'll see it does lift. Oh, it actually lifts perfectly. And always stays in the right sort of orientation. So this will simulate the motion of our bar. The only thing we have to do is if we go enable all contact, like so, you'll notice that we can't pull it too far down so that the lever doesn't go through the floor. And then if we go all the way down this way, you can see it touches the floor this way. Finally, if we just sort of go this the whole way to the point where it's floating and go I for inspect, which it measures the thing, we can measure the distance from that face to that face and confirm that that is 106 millimeters, which means if we do that movement, we will achieve the goal of lifting the 1 kilogram mass 100 millimeters in the air. Thank you very much for your time. That is the simplest design I believe I can build for this project. Thank you very much.